So I'm out here in the courtyard of Duncan Hall near San Jose State University, and I can't really get a good angle with this thing. But the reason why I'm doing this now, I would normally bring all of you down here to do this, but because we meet so late in the evening, the sun's usually not out for too long during that time. So there's plenty of sunlight right now, so I thought I'd do this right now. It's a little after 4 p.m. on Monday, September 16th, 2019. So here we go. Alright, so what I have right here are two different t-shirts, a light color t-shirt and a dark color t-shirt. And what I'm actually going to do is I'm going to take these two t-shirts, lay them out here on the ground in the sun, and give them a minute or two to soak up some sunlight. And then we're going to see how the color of each of these shirts affects their temperature. Alright, so let's do it. First, let me lay out the light color t-shirt. Sorry if I'm getting you seasick. There's the light color t-shirt. And here is the dark color t-shirt. Alright. Now let's let them sit out here for, I'll just wait a minute. So we'll just let them sit out here, take a minute, and we'll see what happens. Alright, so here are the two shirts. They're just sitting there. Nothing's really happening right now. I just grabbed both of these from Target earlier today. But we will actually see what happens in a few moments. One of the things I should mention is that I have them both out in the sun, so there's no shadows, nothing like that affecting them. They're both out in the sun. I guess I want to be a little bit more accurate. Let me try to make this less wrinkly, so there's as little shade on it as possible. Let's just give it another 30 seconds. So, did your football team win this weekend? Get everything you wanted? I'm not a football fan, so. Alright, a few more seconds. Honestly, doesn't take too long to see an effect. Okay, well, let me explain to you what I have in my hand. This is what's called a thermal radiometer. Basically, the way that this works, it's an infrared radiometer. Basically, the way this works is this uses what we talked about last time, which was every object with the temperature above absolute zero emits radiation. And the warmer an object is, the more radiation it emits. This calculates how much radiation each of these shirts is giving off, and then converts it to a temperature. So basically, I can use this to measure temperature. So let's do it. Let's see what we get here. First, let's do the light color t-shirt. Okay. And alright, the light color t-shirt's nice and warm. I mean, we got 90 degrees, nice and warm. It's been sitting out in the sun for a few moments. Now let's look at the dark t-shirt. So 89.8 was the white t-shirt. Now let's look at the dark t-shirt. 105. Very first thing I get is 105. Now I should mention today is a pretty cloudy day. We actually had rain earlier today, so that could affect this a little bit. So we're kind of hanging around 100. Kind of hanging around 100. So we'll just say 100 in this case. So the white color t-shirt was 89-ish, close to 90 degrees. Dark color t-shirt was right around 100 degrees. So the color of what you wear greatly determines how hot the object gets, the clothing gets. And that is very essential for human comfort. So if you've ever heard of the phrase, don't wear white after Labor Day, this is why. Alright, so I'll just take it from there.